Hello everybody. Today we're continuing with trigonometric identities. Learning objective: use basic trigonometric identities to simplify and rewrite trigonometric expressions. We're going to solve some problems today, so let's get to it. Alright, so for exercise 45, rewrite as an expression that does not involve a fraction. As we've done before, first thing we need to do is multiply by the conjugate of the denominator, which is cosecant x plus 1. Cosecant x plus 1. So that's cotangent square x cosine x times cosecant x plus cotangent square x cosine x over cosecant x minus 1 times cosecant x plus 1. Alright? Now, next, what we have here is cosine x and cosecant x. So cotangent square x times cosecant is 1 over sine times cosine x over 1 over or multiplied by 1 over sine x plus cotangent square x cosine x over cosecant square x minus 1. Alright? Now, cosine x times 1 over sine x is cotangent x times cotangent square x, that's cotangent cube x plus cotangent square x cosine x. Now cosecant square x minus 1 is cotangent square x, because according to the Pythagorean identity, cotangent square x plus 1 equals cosecant square x. Move the 1 here. So now what we have is cotangent cube x plus cotangent square x times cosine x. We can take cotangent square x as common, cotangent x plus cosine x over cotangent square x. Cotangent square x and cotangent square x, they cancel out, so cotangent x plus cosine x. Alright? Next is exercise 51. This is a different type of question. Write each expression in terms of a single trigonometric function. So we want the final answer to be like something sine or all sines or all cosines or all tangents, something like that. Now, the best thing to do with these kind of problems is to convert everything to either sine or cosine and see where we get. So let's start. Tangent x is sine x over cosine x minus cosecant is 1 over sine x times secant, which is 1 over cosine x. Let's add these two fractions. The common denominator would be sine x cosine x divided by cosine x. That will give us sine x times sine x, so sine square x minus this divided by this is 1 minus 1. Alright, so now we have sine square x minus 1 over sine x cosine x. Now what's sine square minus 1? That's minus cosine square x over sine x cosine x. Remember, sine square plus cosine square equals Pythagorean identity. So if you bring the 1 here and take the cosine square here, you end up with minus cosine square. Now this cosine cancels out with the square, so now we're left with minus cosine x over sine x. This one is cotangent x, so minus cotangent x, and that's our final answer. And it is a single trigonometric function, which is the cotangent x. Alright, pause the video and let's move on to the next exercise. Alright, again, write each expression in terms of a single trigonometric function. Let's do the same thing. Write everything in terms of either sine or cosine. So cosecant is 1 over sine x. Tangent square is sine square x over cosine square x. Minus secant square is 1 over cosine square x times cosecant is 1 over sine x. Alright, notice that these two are the same. Alright, so we already have a common denominator, sine x cosine square x divided by, so this is sine square x minus 1. Again, sine square x minus 1 equals minus cosine square x over sine x cosine square x. Cosine square x, cosine square x, they cancel out, so we have minus 1 over sine x, which is minus cosecant x. And that's it. One trigonometric function, in this case it's cosecant x. Let's pause the video and move on to the next exercise. Alright, this is something a little bit different. Rewrite each expression as a single logarithm and simplify the answer. This is a good revision of the logarithmic properties. So ln secant x minus ln cosine x. This is the, remember from the logarithmic functions, you know, the quotient property. Ln a over b equals ln a minus ln b. Okay, so this can be written as ln secant x over cosine x. And secant x is 1 over cosine. So this is ln 1 over cosine x over cosine x. Let's say this is 1. So this is ln 1 over cosine square x. Alright. Now we can move the cosine square x up and change the sign of the power. So this is cosine minus 2x. Alright, and this minus 2, using the power property of logarithmic functions, we can move it outside. So we'll have minus 2 ln cosine x, and that's our final answer. So this is a single logarithmic function. Okay, pause the video, go over this one more time, and let's move on to the next exercise. Alright, our last example for today. Rewrite each expression as a single logarithm and simplify the answer. So ln secant square x minus tangent square x minus ln 1 minus cosine square x. We can, simplify before we deal with the logarithmic functions. We know that tangent square x plus 1 equals secant square x. Alright, so secant square x, move this here, secant square x minus tangent x square x equals 1. So this, we can replace the whole thing by 1, ln 1 minus. Now, sine square x plus cosine square x equals 1. So move this here, 1 minus cosine square x equals sine square x. So this becomes ln sine square x. Alright, so again, quotient property, we can write this as ln 1 over sine square x. 1 over sine x is cosecant x. So this is ln cosecant square x. And that's our final answer. Alright. So we did a couple of new exercises today that deal with simplifying logarithmic functions that include trigonometric functions, and we did a couple of examples that we've seen something similar to those before. That does it for us today. Please watch the video, subscribe, like, and leave some comments, and we'll see you in the next video. Alright, stay safe. Bye.